The first one here is actually already graphed for you. So we're not going to, this is sort of a review, right? We're not solving it algebraically yet. So the graphs are already done for you. It says label each with its corresponding equation. So take a look. You have to remember your last unit. Okay? So phones need to be away. So here y-intercept is 6. So there's only one with a positive y-intercept of 6. So that's got to be, whether you check the slope or not, relation number 1. You should check if there's more than 2 to choose from, right? But here, if you go down 1 to the right 1, down 1 to the right 1, you get more points on that line. Next one is solve for y. The y-intercept's -9. We don't have enough of the graph, so it's hard to tell. Looks like it could be -9. So let's use the slope to check. So here's a nice point. Let's go up 2 to the right one. Do we get another point? We sure do. Okay, so that's relation number 2. So the solution to this is this point here, which is 5, 1 in round brackets. And then I'll put squiggly brackets. It just means the set of solutions. Now, yesterday we verified algebraically. Okay, so what we have here for equation relation number 1, our left side and our right side. So our left side is y, which would be 1. Our right side is negative x, which is 5 plus 6. Well, -5 plus 6 is 1. So it should work, right? Because we've graphed them, providing that they're graphed correctly, but we already checked that. So we should get that these both satisfy the equations. So left side, right side. Okay, so then the y value again is 1. Then it's 2 times 5 minus 9. Well, 2 times 5 is 10. Howard. 10 minus 9 is 1. Okay, so both of them work. So we verified it algebraically. Okay, so we've put out the steps here on how to solve by the substitution method. I guess not, tomorrow is a review day, Thursday is the midterm, Friday we'll do the other method of, oh, you don't have school on Friday. Monday, you'll do the next algebraic method. Okay, so, and the reason why we want to do it algebraically is sometimes it doesn't work out to be nice numbers, right? It might be like a fraction of 7 over 13. Really hard to tell on a graph what that is. Okay, so we're going to isolate one of the variables in one of the equations. Choose the easiest one. Okay, it's something that has just an x term or just a y term. Write it as x equals or y equals. So we're good at doing it y equals because that's slope and intercept form. Okay, but we can do it for x as well. Then we're going to substitute that expression into the other equation, not the one that we solve for, into the other one. Then you only have one variable, you're going to solve for it. That's going to be part of your solution. Guys? Then we're going to take that and put it back into the one of the original equations to get the other number. So it's all there that you can read on your own when you're doing this on your own. We're going to do an example. So here, algebraically solve using substitution. Take a look. They're both solved for y. So this is super easy. And we're going to take, I'm just going to take the first one. I'm going to call this equation 1 and equation 2. And I'm going to substitute equation 1 into equation 2. So that means this expression has to go in for y in the other equation. So this is going to be negative x plus 6 equals 2x minus 9. So basically, if they're both solved for y, you're just putting them together. We used to actually call that the comparison method, but it's really a special form of substitution. It's just pretty easy because it's a very easy substitution. So now when we solve for x, I'm going to subtract 2x from both sides. So I get negative 3x plus 6 equals negative 9, because that goes away to 0. And then I subtract 6 from both sides. So again, it's just solving equations back from junior high. So negative 3x equals negative 15, because that goes to 0, and divide by negative 3. Okay, so we'll get x equals 5. Okay, but we're not done. So now you have to take that 5, and I'm going to substitute that back into either equation. I'm going to put it back into equation 1. So then y equals negative 5 plus 6, which is 1. So now my solution is my x value and my y value as an ordered pair. Unless it's an application where you can, you'll need to make a statement about what's happening. Okay, so that's the method of substitution. Okay, now this next step says use the same system, so it's the exact same question. To show that you could have used the expression for x instead of y to substitute into the other equation. So here, if I solve this equation for x rather than for y, so that means I would have, if I bring here, I'm just going to rewrite it up top actually. I'm going to rewrite the equation, negative x plus 6. Okay, so I'm going to subtract 6 from both sides, or what's easier, because x is negative, you should start getting good at this, is you want to make x positive. You want to get x by itself, kind of like when we convert it to general form. So I'm going to add x to both sides. And you could do this all in one step. So I would have x plus y equals 6. That goes to 0. And then I'm going to subtract y. So I'm going to have x equals 6 minus y, or negative y plus 6. But I like having the first term being positive because I'm just substituting in. It's no special form or anything like that. It's not a final answer. So now I'm going to call this my equation 1, this my equation 2, and I'm going to substitute 1 into 2. Oops. Okay, so, so I've got y equals 2, open bracket, where I'm going to put the expression for x, then minus 9. If you want to use a different color, do it. You would put 6 minus y in there. So now when I simplify that, that's going to be 12 minus 2y minus 9. I'm going to add 2y to both sides and collect the constant terms. So that'll be 3y equals 3, so y equals 1. And that's what we got when we did it the first time. Okay, we should get the exact same answer. So we got the y, now we're going to substitute that back into equation 1. Oh, I guess into 1. So we'll get x equals 6 minus 1, which is 5. So you get the exact same solution. Which of those was easiest? The first one I did or the second one? First one, right? Because it was y equals. If both of them are y equals, then that's easier to substitute in. But either of them work. And obviously you get the same answer, right? So, pardon me?
Where do you like? I don't know how you figure out why the second way.
I did find y. The second way, I solved for x and I substituted in to get the y value of 1. Okay. Okay, turn over to the next page and notice they're not as nice. So it's not solved for y or for x, either of them. So you want to look at which equation or equations have just an x or just a y. Okay, so the first one has just an x term plus 4y. The second one has negative x. So either one of those, but I'm not going to use a solve for y and use substitution for these because I would have fractions. That's when we're going to learn elimination next week to make ones that don't have any single terms. But this one, the easiest one is the first. So I'm going to solve this for x by subtracting 4y from both sides. Okay, Miles, can you do this, please? With your pencil. Okay, so I've solved the first one. So that's my equation 1. This is my equation 2. So I'm going to substitute 1 into 2. So take a look. I'm replacing the x. So I copy out the 2y minus, I'm going to put brackets where I substitute the x in, equals negative 26. So my first step is just putting the brackets where the x is. Now, if you want to use a different color, you can. Oops, I tried. Let me try it again. 8 minus 4y is what replaces the x. Can you stop, please? Okay, so now expand the brackets and solve for y. Mate, doing this, please. Okay, so you get rid of the brackets, then collect like terms. And then add 8 here to both sides. so y is negative 3. Once you've got the y value, don't forget to put it back in and solve for x. If you forget the x, you don't get full marks, right? It's a system of equations that cross over in most cases, unless they're the same line or parallel. And so you need both coordinates. So now I'm going to substitute that back into the first one. You can put it into the second one, doesn't matter, but the first one I've already solved for x. Now what you might want to do is go back into the original first one, so x plus 4y, just so that you're not, in case you did the solving for x incorrectly, you're kind of compounding the error. So if I put it back into the first one before solving for x, it's going to look like this. It will give you the exact same answer. X is 20. So now your solution is 20 for x, negative 3 for y in an ordered pair. Okay. Now we've been using x's and y's. Doesn't have to be x's and y's. The next system is a's and b's. Take a look at it though. If I look at the first one and I want to say I decide, because none of the terms there are just a or just b, right? So it means I might have fractions. If I look at the first one and solve for a, I'm for sure going to get fractions, right? Because the 4b will go over and I'll have to divide by 7. If I solve for b, same deal. It'll be fractions. What I notice in the next one, though, is that all of those are multiples of 2. Can you put your phone away, please? Okay, they're all multiples of 2. So I could, right now, divide everything by 2, and I would get 2b plus a plus 3 equals 0. Now, that's good, because now I have just an a term. So that's a nice one I can solve. A then will be equal to negative 2b minus 3. So I basically bring all the other terms to the right. This was my equation 1. This is my equation 2. All of it. I've just rearranged it. That's all. So I'm going to substitute this into equation 1 this time. Because that's equation 2, and it's got to go into the other equation. You can't put it back into the same equation.
Okay, so you're putting 1 into 2?
I'm putting 2 into 1.
Okay. But I thought you were putting 1 into 2 into all 4.
I was.
So what's the difference?
There's no difference. You decide which you're putting into the other.
Oh, okay.
You can rearrange this. I can call this equation 5 and this equation 6. And then I'd be putting 6 into equation 5. It doesn't matter what you call them. It's just one equation has to go into the other.
Okay.
So now if I do that into equation 1, I'll have 7 bracket minus 4b equals 6. And what goes in the bracket is the expression for a, which is negative 2b minus 3. And now expand the brackets and solve for b. So really important that you get your integer skills down pat, right? You don't want to have the wrong signs. It's going to mess you up. Most of the ones that we give you don't have crazy fraction answers. You might get a fraction, but we're not doing like 103 over 27 or like weird fractions, right? So they should be fairly reasonable. Doesn't mean that you couldn't have that, but I mean, obviously we're not trying to It's not about crazy fractions. We want to see the steps of your work. Okay. Collecting like terms here, that would be negative 18b minus 21 equals 6. So that's 27. So b equals 27 over negative 18. Remember, we don't like to show a negative in the denominator, and 9 goes into both of those. So that's going to be negative 3 over 2. Okay. Again, not a crazy fraction. So I'm going to substitute, so that was b, and then I'm going to substitute that into, I'm going to go back into equation 2. Okay. And if I use the solved, like go back and make sure you solved it correctly, but if I use that one where I've solved for a, then it's pretty easy because I've already got a by itself, right? And in this case, negative 2 times negative 3 over 2, the 2's divide out. So we get positive 3, right? Positive 3 minus 3 is 0. Okay, does that make sense? Yeah, it does. Remember getting it 0. Yep. Okay, so then here we'll have, now this one, we're not used to A's and B's. So you could write A equals B equals just together, or as an ordered pair, put it in alphabetical order. So 0, negative 3 over 2. Okay. And you can always check by doing a quick substitution of both of those back into the other equation, right? So 7 times 0 is 0, minus 4 times negative 3 over 2, that's 6. So 6, 0 plus 6 equals 6. So you can always check. Now the next ones have fractions. Don't like, I mean, yes, y has been solved for, sorry, in the second equation, it's solved for y. But, so I might leave that one, but I certainly don't really want to put those fractions back in for y in the first one. Okay, so remember what we did to put an equation in general form. We got rid of all the fractions. So this first one here, I'm going to get rid of the fractions. What would I multiply both sides by, or every term by, to get rid of those denominators? It's okay. Lowest common denominator of both of them, right? 6. So you look at all denominators. So the lowest common denominator is 6. If you do it by 2, you can, but then you're going to have to do it by 3 as well. So here I'm going to multiply by 6. So then you get 3x plus, so I'm going to distribute that. And so when I do, I get 12 divided by 3 is 4y equals negative. So I'm not going to get rid of the denominators there, but I'm going to now substitute this. So this is equation 2. Oh, that didn't write out very well. So substitute into equation 1. So this is going to be my equation 1. right? So I'm replacing the y. So 3x plus 4 bracket equals negative 12. And so I'm going to substitute that 1/4 x minus 5/3. We're still talking. Okay. I might still have a fraction, right? But we'll deal with that as it comes. So here, when I multiply through, first term is good. 4 times 1/4 x is just x. And then 4 times 5/3 is minus 20 over 3, 20/3. Okay, so you could, if you wanted to, you could multiply by 3, right? But then you're going to have to divide at some point as well. So this is fairly manageable. Add the x terms. Take negative 12 and add 20 over 3. Because you had to do that when you did slope-intercept form back in the last unit. So you should be able to add negative 12 plus 20 over 3. And then divide by 4. Okay, so I'll do it both ways. So here 4x equals, that'd be negative 36 over 3 plus 20 is negative 16 over 3. And this is where students sometimes have a hard time with dividing by 4. But what I would say is think about it as multiplying by 1/4 both sides. So then I'm kind of doing this in big writing, but then you'll get x equals negative 16 over 12. The 4's divide out, so that would be negative 4 over 3. Okay. Now, if you wanted to, don't write this down. I'm just going to show you because I'll erase it in a minute. If from this step you wanted to multiply by 3, because you don't like fractions, so if you're not a fan, then if you multiply everything by 3, you'll get 12x equals negative 36 plus 20. So don't write this down unless you want to, because this is just another way. So that's going to be 12x equals negative 16. So x equals negative 16 over 12, which reduces to negative 4 over 3. Okay. So that's a way of doing that without having to deal with fractions as much. Now we're not done. We need to solve for y. So from here, I'm going to erase this in a sec. I'm going to take negative 4/3. I'm going to put it back in. I don't really want to, well, I guess I could. I could put it back into the y equals, because then it's solved for y. Or I could put it back into the equation 1. Here's how you can tell what might be easier. Look at the denominator here. It's a 3. If I look up here and put it in for x there, I'm going to multiply by 3. Well, that means the 3's will divide out. So that's going to be pretty easy to solve. If I put it back into the second one, I'm going to have fractions, and you'll need a common denominator. So I'm going to substitute. So here, remember I said I'm just going to erase this because that was extra. Okay, so I'm going to here substitute into equation 1. Into the form where I've gotten rid of the denominators. Okay, so that will be 3 bracket for x plus 4y equals negative 12. And I put the negative 4/3. And you can see the 3's divide out. So I get negative 4 plus 4y equals negative 12. 4y equals, so I add 4 to both sides. That was going to be negative 8. So y equals negative 2. And then you just write it as an ordered pair, x and y. Okay. If you wanted to, back here, both of them, you could multiply the second one through by 12 and get rid of the fractions and then solve for one of the variables. But this, I think, was probably the easiest method because it was already solved for y. And then the last one has decimals, okay? And again, we don't, well, it has decimals, and then the first one also has brackets. So we want to make sure there's no brackets. We don't want brackets within brackets when we do substitution. So I would take the first one, oops, and expand out the brackets. So 0.2 times 5 is actually 1. So that's going to be x, which is nice, minus 0.2 times 50 is going to be 10 equals 2y. Okay, so right away I have, I can solve for x. The second equation has a lot of decimals, so I could put that in. I would still have decimals. I might get rid of the decimals in the second one as well. So I just expanded the brackets there, and so there were no decimals. This one, there's no brackets, but I've got 0.2x, negative 0.3y, I've got 0.8. What number could I multiply every term there to get rid of the decimals? 10, right? To move the decimal place 1 to the right, I could multiply by 10. So if I take this and multiply by 10, I will get 2x minus 3y equals 8. Okay? Now it's a really nice equation. No decimals, no fractions. The first one I can solve for x easily. By adding 10 to both sides. Oops. So that's my equation 1. Actually, I'll put the 1 over here. 1 here, 2 here. So I'm going to substitute this into equation 2. So when I do that, I will have 2 bracket 2y plus 10 minus 3y equals 8. If you do a substitution and you still have 2 variables, you did something wrong. Sarah, are you doing this? Okay, expand out. This is nice because 4y minus 3y is just 1y, right? So that's going to be y plus 20 equals 8. So y equals negative 12. And then I'm going to substitute that back into equation 1. Okay, the form that I solved. Did I do something wrong? Okay, so then what do I get? I get x equals 2 times negative 12 plus 10. Which is negative 24 plus 10, which is negative 14. Okay, so ordered pair is negative 14, negative 12. Oops, that didn't look very good. Okay. Just a sec. Yeah, so then, I don't know why I didn't copy all that down. So at the bottom of that page, it says, when solving algebraically, if both variables disappear, so if you substitute an equation into the other, and then you have no variables when you collect like terms, that means it's either parallel and coincident, so that means infinitely many solutions, or there are no solutions. Okay, so let me just extend down here. So for example, if I have y equals 2x minus 3, you don't have to write this down, I just want to show you, as my one equation, and then I have 2x minus y minus 3 equals my other equation. So a different form of it, or a different form of an equation. What you'll notice, if I substitute 1 into 2 here, so that's already solved for y, then I would get 2x minus 3 minus 3 equals 0. And what happens is the x terms go away, right? When I get rid of my brackets, I will get 2x minus 2x plus 3 minus 3 equals 0. Well, 2x minus 2x is 0. 3 minus 3 is 0. So this will be 0 equals 0. So those lines are exactly the same. If I solve for y here, you can see they are exactly the same. So if you do that, if you don't notice that they're the same line, you're going to get down to 0 equals 0, which means there are infinitely many solutions. I can't read what I just wrote there because it's so slow, but it's going to be infinitely many solutions. And so that equation of that line is your solution. I got to fix that. It's close. Infinitely many. Now, if I had, say I had this first equation. So this is a different system. And then I had 2x minus y minus 5 equals 0 as my second equation. Then when I substitute those in, the x terms are going to go away. So I'm going to have 1 into 2. So I'll have 2x minus 3 minus 5 equals 0. Okay, and then when you collect like terms there, you're going to get 2, well, I'll expand the brackets. And you can see you're going to get negative 2 equals 0. Well, there's no place in our world where negative 2 is equal to 0. There's no values of x that you can put in there. So this means there are no solutions. And you can tell this first equation was 2x minus 3. If I solve this one for y, I get 2x minus 5. So they have the same slope, but different y-intercept. So that means two parallel, I always use my pen, so two parallel and distinct lines. They never touch. Okay, so that's what it means at that bottom of that page. Okay, and so you still have about 15 minutes, so I would suggest that you do a practice or two of the questions there. And then tonight, spend time studying for your midterm.